Welcome back to Raw. In this demonstration, I'm going to show you what aggregation looks like. Aggregation is the single most widely experienced problem in SAXS. This particular example is unique in that it just so happens that a very aggressive centrifuging of the sample will rescue it from aggregation. So you can see what the sample looks like before and after. This is also a unique example in that we're doing a buffer that contains some detergent micelles. And that's usually a very tricky thing in SAXS, but we'll show you what a good buffer subtraction looks like under those conditions. So I've already changed to the tutorial data aggregation folder, and you'll find in there something called profiles only. And just go ahead and load all of those examples by highlighting them and plotting them. Okay, and then go to the manipulation window, and what I want to do is the two that are labeled S underscore after and S underscore before, select those two, right click your mouse and go move to bottom plot. Okay, so what I've done is to separate the actual solution and buffer data from the subtracted buffers. Okay, so I'm going to turn everything off except for the buffer and the buffer DDM. So I wanted you to see this example because blue is a characteristic buffer. It's just sort of flat and uninteresting. This is a buffer without any detergent in it. And then with the detergent added, you can see that it goes up, comes down, almost touches where the buffer is, and then it comes up again. This is very characteristic of micelles in solution. I'm going to zoom in a little bit just so you can see the difference a little bit more clearly here. This is a very dilute solution and you really can't see it very well, but you'll notice right there that the curves don't quite cross, but the micelle sort of kisses the curve here and then rises up again. So that's very characteristic. Now I'm going to turn on sample before centrifuging and sample after centrifuging. Now you can notice already that there's been a change here. Before centrifuging you have this rapid rise of the curve, and I can sort of zoom in a little bit on that maybe. You can see a little bit better here, which is usually symptomatic of some aggregation, and after centrifuging things have moved down a little bit. Okay? So you could go ahead and subtract those curves if you want. I've already done that down here, and so I'm going to go ahead and display those already subtracted curves. Now they don't look particularly interesting. I'm going to make sure I put it in the ordinary log-lin mode. Okay, yeah, so here you can see it much more, the aggregated curve just looks a lot like radiation damage. It's not a very straight looking curve. All right, but what the real telltale is when we try to do the Guinea analysis. So if we do the before Guinea analysis, so you go and invoke the Guinea tool, and you can see there's a region here that looks like it might be linear, and you zoom into that. And I'm going to bring the Guinea region down. Now this is quite common. You'll see a case where it's sort of a curve looks like it wants to be linear, and then it twists upward. And if we go all the way in and we try to find a nice flat Guinea region, you'll notice we just can't do it. It's always got a smile to it. See, we're at a QRG of 1.88. We're nowhere near 1.3 that we need to be, and we have this characteristic smile. And you can just keep going in, and the situation just doesn't get any better until you run out of points. Okay, you can take it down. You can take it down to a few points, but that's too far down. Now you could attempt to extract a Guinea from this flat region here, and you almost get the right answer doing that. You'll notice it actually looks half decent, but you'll notice that your QRG is just ridiculously high, and you can't really, you can try to bring it in, but you can never get it in there. But it turns out that in fact the RG is rather close to 62, as you'll see in a moment. So that's really what's going on here, is that you've got some large junk in the mix that is messing up your Guinea plot, and so you're seeing it almost flattens out and then it sort of charges upward. So I'm going to get rid of this one. Now let's look at what it looks like after aggressive centrifuging. Sometimes you can rescue samples by centrifuging them hard for a long time. In this case, the sample had to be centrifuged at 70,000 RPMs for half an hour, which is really quite a lot. So let's do the Guinea A once again. And I'm going to go down to 0.150. And you can see this time is a beautiful flat line. This is really what what it should look like when there's no aggregation. And you notice it's actually flat long before we've reached QRG of 1.3, which is probably indicative of some kind of a disk shape. But let's move it down to where it ought to be. Okay, here we go. So at QRG of 1.3, 1.296 in this case, notice that we still have a fair number of points on the curve. The QRG at the minimum point, that's right here, is 0.58, which is less than half of 1.3. So that's very good. We have enough points to have a valid Guinea A plot. And you'll notice here that the RG is 68 in this particular sample. That concludes this demonstration.